Welcome to the project demonstration of human body temperature and heart rate monitoring along with alerting system. So the main application of this project is we are going to get the human body parameters like heart rate from this pulse sensor and temperature from this temperature sensor. So these two sensors will provide us the health parameters, that is the heart rate and temperature, that will be continuously monitoring and displayed on the 16:2 LCD screen. And if is there any abnormality detected, like if the temperature is above 100°F or if the heart rate is above 100 beats per minute, so then the system will provide us the alertings through this buzzer as well as alert messages on the 16:2 LCD screen. So to achieve these features, we have interfaced these two sensors are interfaced to the A0 A1 pin of our PIC16F72 microcontroller, and based on the system reading, alert will be provided to the buzzer which was interfaced at the pin number C4 and B2 to B7 for the 16:2 LCD screen. So these are the main input and output connections of our project, and the whole system getting power supply from this adapter which will take 230 volts AC input and provide us the 5 volts DC output, as the operating voltage of our whole system including sensors and output modules is 5 volt. So it will take 230 volts AC input, and it has the 4 stages inside this adapter, so which has the a transformation, next rectification and filtration and regulation. So transformation will shift down the 230 volts AC to 12 volts of AC, rectifier to convert the AC to pulsating DC, filter to remove the pulses and provide us a pure DC of 12 volts. And as we discussed, the operating voltage is 5 volt, so that we need to regulate that 12 volts DC to 5 volts DC using 780 regulator. All these 4 stages presented in this adapter. So once it get the 5 volts power supply, then it start reading input from these sensors and providing the output. And coming to this motherboard, so it has like reset switch to just restart the microcontroller, and the steel plated one is a crystal oscillator to provide the 20 megahertz of oscillating frequency to the system. The 20 megahertz clock frequency nothing but to execute the instructions, reading of input and controlling the output modules is the instructions that will be executed based on this clock pulses. And here the reset system nothing but reset the system nothing but it only reset the microcontroller, means restart the microcontroller, it won't erase the program. So let us see demonstration. So initially welcome message displayed on the LCD screen, and thereafter as of now there is no input to the system. The BPM, the beats per minute, is 0. Temperature is just like room temperature. So when we place the finger on this gently, then the temperature slightly will be increased slowly, and we can get the BPM values is 64. So if you want to make abnormal BPM, means abnormal heart rate, and then just by tapping on this one, so we may get the values of high heart rate alerts, so that we can provide the audible alerts. So just keep on tapping that, so that we are making a malfunction input to this pulse sensor to provide the high alerts. So it will be difficult, but we will try that. And coming to the temperature, you can just increase the temperature over here, so we can see the temperature getting increased, right? Right, let us check with again high temperature alerts. So when we are increasing that, when it crosses the 100°F, then high temperature message alert displayed on the LCD along with the audible alerts. When again it is coming down to normal temperature, then the buzzer will be off and alert message will be goes. Right. Okay. So in this manner, continuously heart rate and temperature monitoring will be achieved with the help of PIC microcontroller. Right.